Question 11, Part C. Solve x over x minus 3 less than 2. Let's start by analysing the left-hand side of the inequality. Now, the denominator is x minus 3, and we can't have a denominator of 0. So x minus 3 cannot equal 0, because we'll have division by 0. Hence, x cannot equal 3, and that's our first critical point. To establish other critical points, we can multiply both sides of the inequality by the square of the denominator. And by doing that, we don't need to flip the inequality symbol because we're multiplying by something that is positive. So multiplying both sides by the square of x minus 3, we get x times x minus 3 in brackets squared over x minus 3 less than 2 times x minus 3 in brackets squared. Now, an x minus 3 up here will cancel with the x minus 3 here. So that square will disappear and this denominator will disappear. So the left-hand side becomes x times x minus 3 in brackets less than 2 times x minus 3 in brackets squared. Now we can expand both sides of the inequality. So expanding the brackets here and here, we get x squared minus 3x less than 2 times x squared minus 6x plus 9, since we have a perfect square here. And that becomes x squared minus 3x less than 2x squared minus 12x plus 18. Now I'm going to move these two terms over to the other side. So we get 0 less than x squared minus 9x plus 18. So we end up with a quadratic inequality. And just rewriting the inequality so we have the 0 on the right-hand side, so it just looks a little neater. X squared minus 9x plus 18 is greater than 0. Now, if we graph x squared minus 9x plus 18, we get a concave up parabola. And we're interested in the values of x where the parabola is positive or above the x-axis, since the inequality is greater than 0. So the critical points are found by factorising the left-hand side. So we get x minus 3 in brackets times x minus 6 in brackets greater than 0. So the critical points are 3 and 6. And we want the intervals where the parabola is above the x-axis. So that occurs when x is less than 3 or x is greater than 6. And that is our solution. Therefore, x is less than 3 or x is greater than 6.